Let's talk about the next problem. This one is about projectile motion. The problem here says the ceiling of a long hall is 25 meters high. What is the maximum horizontal distance that a ball thrown with a speed of 40 meters per second can go without hitting the ceiling of the hall? So we have been given an upper limit on how high the ball can go. With that limit in mind, we have to maximize the range of the ball. So essentially, if I visualize the problem like we always do, let's say this is our ceiling of the hall, which is 25 meters high, and this is our ball which is being thrown. So first of all, with a velocity 40 meters per second, we throw it at an arbitrary angle θ1. So over here, I have thrown the ball at an arbitrary angle θ1. It can still go a bit higher. So I increase the angle to θ2 and I throw the ball again. Now once again, there is still more room for the ball to go higher. And then ultimately we throw the ball at an angle of θ3, which is our final angle. And we see the ball goes all the way close to the ceiling and comes back down there. Now clearly this curve here, the external curve, is our limiting condition when our maximum height is equal to 25 meters and this length is the maximum range when we have a limitation on how high the ball can go. Clearly you cannot apply the formula for maximum range here because in that case we have no control over how high the ball goes. The problem has clearly put a limitation on how high the ball can go, so we have to keep that in mind while we are solving the problem. So once that is given, we can directly use the idea that we know the maximum height is equal to 25 meters. In that case, what is the value of range? So doing that, I can say that max height is simply u square sine square theta by 2g. And here this angle theta is the angle θ3 that we were talking about. I have simply taken as theta because θ1 and θ2 are of no interest to us anyway. So this value simply comes out to be 25 meters. If I put the value of u as 40 and the value of g as 10 meters per second square, the expression for sine square theta I obtain is 5 by 16. Now from here sine theta is clearly square root of 5 upon 4 and angle theta value can be calculated. Now once I calculate the angle value theta, I can directly put that angle value in the second expression for the formula of maximum range, which is u square sine 2 theta by g. But you'll have to use calculators for the same, so I'll be going through a different approach to solve this problem. So here we'll sustain the value for sine square theta as 5 by 16 and we'll start solving this problem. From sine square theta, we'll calculate the value of cos square theta. So cos square theta will come out to be 1 minus 5 upon 16, which will be simply 11 upon 16. Now we'll take the formula for maximum range, which is u square sine 2 theta by g, and we'll put the value of u square and g, which is 40 square and 10. Now maximum range essentially simplifies itself into 160 multiplied by sine 2 theta, which has been expanded as 2 sine theta into cos theta. Now we have found the value of cos square theta and sine square theta, so we'll put the value of each of them directly, which will come out to be 320 into square root of 5 upon 4 into square root of 11 upon 4. If I simplify this value, it comes out to be 20 multiplied by square root of 55, which upon simplification gives me 148.32 meters. So this is the maximum possible range to which I can throw the ball in order to not hit a ceiling wall which is 25 meters high. The method was very straightforward. We fixed the maximum height value and then we ultimately obtained the value of maximum range. As a student, you can directly proceed right from here by calculating the value of sine theta and ultimately theta and putting that angle in the second expression. But if you want to avoid using calculator, you can also proceed with this method and ultimately reach at the same answer. I hope this method is clear to you. Thank you.